Hi friends, welcome back to another project of FMT. So today we will be having a project on semiconductor manufacturing process. So we will basically build a classifier to predict the pass-fail yield of a particular process entity and analyze whether all the features are required to build the model or not, right? So first we import things like if you are working on Google Drive, so you will have to mount the Google Drive. Then here we are importing all the libraries like to suppress the warnings, we are importing warning. So OS is of course again we mainly used with the Google Drive. So this is used to provide a way of using operating system dependent functionality. So we use it for setting working folders, right? Then pandas, numpy, of course. So matplotlib, all these are visualization. Then scikit-learn features various classification, regression, and clustering algorithms, right? Now then we are ignoring the all the warnings, then displaying all the data frames in columns. Then to set the limit to decimal, that will be using up to 3 decimal. Then display all data frames row. Now importing and understanding the data. So this is the signal data CSV, which I'll provide the link in the description. Also you can easily access it and use it accordingly. Now to display the top 5 rows of the data frame, so df.head, of course, so it will return top 5 rows. So here you can see we have these much of columns, right? And if we check the shape, so this is the columns and the rows. Then a data frame has 592 columns and 1567 rows, right? So if we use df.info, so it will return the information. So there are 1567 rows and 592 columns. There is one int type features, one object type, and remaining 590 float type features. The number of rows are less compared to given features. So data cleaning, if we do, so data preparation is the process of cleaning and transforming raw data prior to building predictive models. Check for missing values. So missing values equals to df.isNull.sum.any. so print the number of missing values of each variable. Again we are getting it as true. So let's draw features having more than 700 missing values. So again d equal to df.isNull and sum. J we are having empty list. Then for I in d.keys, right? So we are dropping all the features that are having more than 700 missing values. Now df new df.drop, so j x is equals to 1. So this time the shape that we have gotten is this. Now df new dot isNull any, so again true, right? So that means imputing missing value of remaining features with now we can use with their mean values. So dff equals to df new dot fill na df dot new, then we'll fill the na with mean, right? If there are any na, that is no. So df dot describe, so we'll get the 5-point summary where we will be getting the count, mean, standard deviation, minimum, maximum, and interquartile ranges. Now taking care of missing data using imputer. So from all these, right, now we have already dropped features having more than around 50% of missing values. We will check features importance and take a call if we can further reduce the number of features like other method. Then we can drop features having 0 standard deviation post checking their importance. We can use forward selection or backward eliminating method for feature selection. We can apply PCA to reduce the overall number of features. Now data analysis and visualization. So perform detailed relevant statistical analysis on the data. Perform a detailed univariate, bivariate, and multivariate analysis and appropriate detailed comments after each analysis. So stats dff.describe, so it's stats we are getting like this. Standard equals to dff.std, access equals to 0, std equals to 0 dot shape. So these there are 116 features having the same values for all the rows. So 0 standard equals to std, where std equals to 0, column to drop 0 std dot index dot to list. Non-zero std dff dot drop columns call to drop x is equals to 1. Non-zero std dff dot shape, so distribution plot to see first 4 columns distribution. So plt dot rc parameter figure dot fig size 18 and 16, plt dot subplot 2 to 1, sns dot displot dff1 color equals to dark blue, plt dot title first sensor measurement font size equals to 20. Similarly, we are doing it for second sensor measurement, third sensor measurement, and fourth sensor measurement. So you can see that this is what we got the dist plot. So for first, second, third, fourth measurements. Now we can see the feature 1, 2, 3 are quite normally distributed, where feature 4 is centered around 0 and has a long tail toward the right side, right? You can see like this. Now a core correlation dff.core, so figure size, if we print the correlation between features, so oh my god, here you can see the correlation, right? So there are too many features since bivariate plot is messy. You can see here we do see black color in non-diagonal places where, which tells us that there are correlated features. So here you can see. Now data pre-processing, so select independent features for model building. So id is dropped, so x equals to dff dot drop pass fail time that we have, x is equals to 1, y equals to dff pass fail. So split data into train subset and test subset. So here x train x test, y train y test, right? Train test split we are doing, checking the dimension of the train and test subset to print a dimension of train set. So we have print x train dot shape, similarly print x test dot shape. So this way we will get for train and test x train dot head of 2, so top 2 values, check for target balancing and fix it found imbalance. So smooth, that is synthetic minority oversampling technique. So pd dot value counts dff pass fails, right? -1 and 1. Before oversampling count of level 1 and count of level -1, so respectively we are getting these. Now using smooth, so after oversampling the shape of train x is equal to this, and after oversampling the train of the shape of train y is this, right? Similarly, after oversampling count of level 1 and count of level -1, so these values that we have been getting. Now pd dot values count y test, so -1 for -1 440, for 1 31. Standardize the data if required. So from sklearn.preprocessing import standard scalar, creating a standard scalar sc equals to standard scalar, so fitting independent data to the model, xtrain sc, xtest sc. Check if the train and test data have similar statistical characteristics when compared with original data. So dff.describe, right? Similarly, xtrain res df equals to pd dot data frame xtrain res df dot describe. So similarly, count, mean, standard deviation, min 25. So these are nothing but the interquartile ranges. xtest dot describe, so here we have the described function. We see that test data is quite similar to the original df. Analyzing resampling train data, we see that mean is quite similar to the original df, but there is some difference in the standard deviation of a few features. We could perform further statistical analysis to confirm if there is any significance difference. Model training, testing and tuning, so logistic regression LR2, logistic regression C equals to 1000, penalty equal to L2. LR2.fit xtrain sc, ytrain res. Now y prediction LR2, so LR2.predict xtest sc, print accuracy score y prediction LR2 y test. CM equals to confusion matrix, so y prediction LR2 y test, and then we have CM, so accuracy score is around 86%. Import function for ridge regression, so sklearn.linear model, import ridge classifier, so tuned parameter that we have alpha 7, 8, 9, 10 and 11. Then ridge classifier, ridge grid dot fit, and finally we do the best parameter for ridge regression, so ridge grid best parameter. So this case we got alpha 7. Similarly, ridge regression for alpha 7, LR2.fit xtrain sc, ytrain res. So y prediction LR2 equals to LR2.predict xtest sc, print accuracy score, so accuracy score equals accuracy score of y prediction LR2 and y test. So if we get the accuracy score, so we have this nearly 83%, right, array, and this is nothing but the confusion matrix for y predict LR2 and y test, right. Now regularization reduce the accuracy, but minority class is better represented. If we similarly, if we try the random forest, so after trying the random forest classifier, this is the accuracy score 0.93 and 0.93, right, and confusion matrix precision score. So we see that the accuracy of logistic regression model is comparatively less than the random forest model. Precision is very low in the case of the random forest. The default random forest model is based toward one class even when we are trying the model on balanced data set. Now applying grid search CB to find the best model with the best parameter. So grid search CB we are importing from model selection, similarly classification report from matrix. Now model we are having a random forest classifier of 50 n estimators and Guinea as criterion, right. These are the parameter: max depth, min sample split, min sample leaf, right. So finally if we print the best accuracy, we get the 99%, best parameter we get all these, right, and the classification report you can see the precision, recall, F1 score and the support. Now model equals to random classifier and estimator equals to 50, criterion again Guinea, max depth equals to 100. So model dot fit of X train SC, Y train RES. So print accuracy score, confusion matrix and precision scores. Accuracy score is 0.92, confusion matrix 438, right. This is nothing but a confusion matrix. Precision score we got this. Now features equals to dff dot column, so importance model dot feature importance, index is np dot arg short, right. Figure size, title we are giving, right. Now we have bar h, so again due to huge values, so this is what the bar plot will looks like. Now similarly for importance, model dot features importance, if we get that in the pie plot, so here you can see there are many features gives very little importance, right. Now feature df equal to pd dot data frame, importance we are having, and index extrain columns, feature df dot shape, so 558 and 1, importance of non-zero. So all this, now we are having the PCA. So let's say dff dot head equals to, for head 2 we have these values: df final, df dot drop, time and pass fail, right, and xs1 that is permanently, target equal to df of pass fail. Now split data into train subset and test subset. So train test split we are doing, right. So df final, target, test size, random state, stratify, target, right. Standardization, so from sklearn pre-processing, import standard scalar. So creating a standard scalar, sc equals to standard scalar, so fitting independent data to the model. So xtrain standard, xtest standard, right. From sklearn dot decomposition, import PCA. So PCA equals to PCA, random state equals to 1 2 3. So PCA dot fit df final, so features equals to range PCA of n component, plt dot figure, so figure size equals to 2010, right. Plt dot bar features, PCA dot explain variance color, light sky blue, then plt dot x label PCA features and variance, similarly plt dot x ticks features and plt dot show. So here you can see how we get it. Now from sklearn dot decomposition, print PCA. So PCA equals to PCA and component, that is 50, taking 50 component, data reduced to PCA dot fit transform, xtrain standard, right. Data test PCA dot transform, xtest standard. So model we are having random forest classifier on 50 n estimator, Guinea as criterion, and max depth equals to 100. Model dot with data reduced, y train, y prediction rf equals to model dot predict, data test, accuracy score, confusion matrix and precision score that we have. Accuracy score is 0.92, confusion matrix, precision score is again 0.004. Now post training and conclusion. So like if we try the KNN, choosing the k values. So again importing accuracy score. So my list of range 2 to 15. Now neighbor of k neighbor classifier, right? AC scores we are having. So perform accuracy matrix for values from 1, 3, 5 up to 19. So for k in k list, and if we apply the method of k neighbor classifier, so the optimal number of neighbor is 2, right? Now from sklearn.neighbors, import k neighbor classifier, again k neighbor classifier on n neighbor 2. Okay, now knn.fit xtrain sc ytrain res. Now y predict knn dot predicted xtest sc. So if we print the accuracy score, we get it 0.5520, and of course the confusion matrix. Then if we try the gradient boosting, so after trying the gradient boosting, we will again get the accuracy as 86%. So you can see the difference between the k neighbor classifier and the gradient boosting. Now sklearn.model selection import grid search, sklearn.matrix import classification report. So model, again we are having gradient boosting classifier on 100 and estimators. Parameter, of course we are passing, making a grid search model here and getting the result now, and printing finally the best accuracy, this one, the best, this one, the best parameter, and finally the classification report. So finally if we check this conclusion, so we tried the following models: KNN, that is giving poor accuracy; logistic regression, good accuracy, able to predict minority classes as well; random forest, biased toward majority classes; gradient boosting, biased toward majority classes. We would prefer a logistic model as it is giving decent result and it is able to predict both classes with decent accuracy, right? So pickle the select model for future use. Of course pickle, we wrap up it for future use. So save the train model as a pickle string. So saved model equals to pickle.dumps. So we are having this lr2. Now loading the pickle, so model from pickle, suppose next time you want to use the same model, so pickle.load that saved model, predict, use the loaded model to make prediction. So now we can directly use our loaded or the pickled model, right? So xtest sc, again you can see if we get the confusion matrix, so it is giving the nicely. Now there are some conclusion and improvisations. So there were around 592 features which came down to 558 after treating missing values. So this is what we observed in the above statements, right? Similarly, target class is highly imbalanced, hence most of the algorithm are biased toward majority classes. And let's say we used grid search for selecting the best parameter. Of course, detailed suggestion or improvement or no on quality, quantity, variety, velocity, veracity, etc. on the data point collected by the bank to perform to better and analysis in the future, right? So we can use forward selection or backward elimination for selecting relevant feature. We require more data points as there are many features. We can try multiple ways to balance the target class. We can try PCA to reduce the number of features. Now we can do some future further explore, like we can use the one class SVM. So here I just introduced it. So if you apply the one class SBM, kernel is RBF, degree 3, gamma value, NU, and max iteration, right? And if you do model.fit on the xtrain res, ytrain res, so later if you print the confusion matrix, so here you can see it. Hope guys this video helped you a lot for your particular problem, right? And hope you got some ideas like how we can frame our problem statement into the real conceptual solutions. So this was all about this video. Thanks for being with us. If you enjoyed, please do like, share and subscribe, and we'll be back with the next video very soon. Till then, all the best. Have a good time.